Hi, welcome. My name is Brian Chan. I'm the Regional Technical Manager for the South Central United States. And today I'll be presenting video surveillance backhaul. The time right now is 9 a.m. I think we've got a few attendees. So let's give the others about a minute or two before we get started. All right, so it looks like we've got a few more attendees, so we'll go ahead and get started. The time is 9:02. This webinar is supposed to last roughly an hour, but it'll likely be a little shorter than that. Again, welcome. My name is Brian Chan. I'm the Regional Technical Manager for the South Central United States, and today I'll be presenting video surveillance backhaul. So video surveillance is a growing market. It's currently valued at 36.9 billion, and it's expected to reach 68.3 billion in the next 5 years by 2023. So with applications like asset monitoring, theft prevention, vandalism deterrence, and employment safety, it plays a key role in any security system. So when people think about video surveillance, they typically only think about the video surveillance cameras. However, video surveillance is more than just about the cameras. It also involves the network that provides connectivity for the cameras back to a central location, whether it's a NOC or Network Operations Center or a server or even to the cloud. It does require a robust network. So that can either be achieved through a wired option using copper or fiber, which can be very prohibitive if you build your own, or very costly if it's a recurring fee if you're leasing those assets, or you can create your own wireless infrastructure using unlicensed or licensed point-to-point backhaul or multi-point. So purpose-built outdoor wireless network solutions can provide cost-effective, high-performance communications infrastructure. And Cambium Networks specifically has several options for providing video surveillance connectivity, and it can empower public and private entities to support public safety, asset protection, and security initiatives. So Cambium Wireless Broadband is a proven solution. So we have several different options within our portfolio for not only multi-point, but also for point-to-point. And so we can achieve high performance, being able to deliver high throughput. In terms of megabits per second, we can achieve hundreds of megabits per second, including over 1,000 megabits per second with some of our licensed point-to-point solutions. We also are able to deliver highly reliable links, especially if you design them adequately. We are able to deliver over 5 nines or even 6 nines of reliability on each of our wireless links. And our solutions are also scalable and secure. So we are able to deliver up to 60 to 120 connections off of a single ePMP access point, or up to 238 connections off of a PMP 450 access point. And in some of the upcoming slides, we'll take a closer look at the different platforms solutions and different performance characteristics and statistics that are associated with each of these different platforms. And as far as security goes, we are also capable of supporting 128 and 256-bit AES encryption for encrypting and securing data that is being transported across a Cambium wireless network. Fast installation is also one of our characteristics. So with a wireless system, you can deploy a point-to-point link or multiple point-to-multipoint links in a matter of hours, as opposed to days with wired networks. Typically, it will take days to deliver connectivity, either through trenching or installing copper or fiber lines. Also, easy planning and management. So we have planning tools like Link Planner and management tools like cnMaestro, which is an NMS tool or network management solution that allows you to manage and monitor all Cambium devices in a single pane of glass. And also, again, as far as reliability goes, as long as you plan links adequately, you can deliver links that are 5 nines or even 6 nines reliability. And also the mean time before failure of a lot of our platforms is in excess of several decades. Like the PMP 450, for example, has a mean time before failure that is over 40 years. And some of our unlicensed and licensed platforms have mean time before failure of over 110 years. Looking at the illustrations in the very top, at the top left, this is a hub and spoke topology. So this is just showing the flexibility of Cambium and the different network architectures and topologies that we support. So on the top left, you've got a hub and spoke with a tower that has multiple access points that can provide perhaps 360 degrees of wireless coverage, connecting multiple video surveillance cameras back to a single location. And then from there, you can have a high throughput backhaul solution delivering all of that aggregate data to a network operations center. The illustration in the top right is a linear architecture. So it starts out with a hub and spoke. So there's a high throughput backhaul link that connects to a central location that delivers data in 360 degrees. And from there, you can grow your network using edge access with point-to-point links that extend the network to the edge. So taking a look at some of the different options that exist in the Cambium portfolio, we have a wireless fabric of connectivity, and this includes point-to-point backhaul, as well as point-to-multipoint, Wi-Fi, and even industrial IoT narrowband radio connectivity. So as far as point-to-point goes, we do support long-range connections over licensed microwave or unlicensed backhaul. For a licensed microwave, we do have the PTP-820 platform, which is capable of delivering up to 1.2 gigabits per second of full duplex throughput. For unlicensed backhaul, we've got a few different options here with the PTP-550 and the PTP-670, which operate in unlicensed bands, covering 5 gigahertz as well as 2.4 and even public safety 4.9 for delivering up to 450 megabits per second of aggregate throughput for the 670 and up to 1.4 gigabits per second of aggregate throughput for the PTP 550. For point-to-multipoint, which will probably play a bigger role for a lot of the video surveillance network connectivity requirements, we do have several options here as well with ePMP and PMP 450. PMP 450 operating in the lightly licensed band or CBRS band of 365 gigahertz. It also supports public safety 4.9, and both ePMP and 450 also exist in 2.4, which is the ISM band, as well as all of the 5 gigahertz bands, including 5.1, 5.2, 5.4, and 5.8. Wi-Fi doesn't necessarily relate directly to video surveillance backhaul. However, at locations where you do have connectivity for your surveillance cameras, you can also offer Wi-Fi at those locations as long as you have connectivity with a Cambium solution like an enterprise-grade indoor or outdoor CN Pilot E400, 500, 600, or 700, not only to extend your network to provide Wi-Fi access, but also if you want to, you can provide guest access as well. Industrial IoT, so that's Internet of Things, narrowband SCADA wireless backhaul. So SCADA is supervisory control, and data acquisition. So we do have narrowband radios that operate in very small channels, like 12.5 kilohertz, 25, and even 50 kilohertz, that are delivering very low throughput for SCADA type traffic. So again, this doesn't necessarily relate directly to video surveillance backhaul, but it can run in parallel where you may have some sort of sensor at the location where you want to have video surveillance, providing SCADA traffic back to a NOC. And so we do have narrowband IoT radios that operate in licensed and unlicensed bands, including 220 megahertz, 450, 700, and 900 megahertz. We also have a cloud-based end-to-end management platform. So this was grown from the ground up in-home within Cambium Networks, sorry. So this is called CN Maestro, and this is the NMS platform that allows you to manage and monitor all Cambium devices in a single pane of glass, pushing out configuration templates as well as software updates, and just monitoring the overall health of your system. So taking a closer look at some of the Cambium solutions and what they look like, going from left to right, you've got point-to-point, multi-point, and Wi-Fi. So with point-to-point, this is focusing more on our unlicensed portfolio. There isn't a graphic of the licensed solution, but there is a slide that will cover that a few slides from now. So for unlicensed point-to-point, we do have the 670, which was launched recently in 2017. So this replaced the Motorola PTP600, which was the gold standard for over a decade. So this was originally designed for the British military, and it's since evolved to have better system gain, larger channel sizes, higher throughput, basically to deliver more capacity over a point-to-point link between point A and point B. So this is a very robust radio. It pioneered some of the technologies that a lot of the other unlicensed point-to-point platforms do support today, like adaptive coding and modulation, as well as dynamic spectral optimization, where the radio has the intelligence to select the cleanest channel possible, and if interference starts to increase in an active channel, it will select the cleaner channel to improve the signal-to-noise ratio to spend more time in the higher modulation modes, delivering more throughput, as well as increasing the overall link reliability and decreasing the overall downtime. The PTP 550 was launched fairly recently, towards the end of 2017 or the beginning of this year. So this is based on a component off the shelf for the mass market 802.11ac chipset. So this is what allows us to offer this at a very low and cost competitive price point. And so this will support up to 1.4 gigabits per second of aggregate throughput. So it is much higher throughput than the 670. And it's also a very capable product because being based on AC chipset, it can deliver 256 QAM. It supports 80 megahertz channels, and it also supports something that's very unique to Cambium that doesn't exist in the rest of the industry, which is asymmetric non-contiguous channel bonding. So this is the ability to bond two channels that are non-contiguous. They can even be in completely different bands like 5.1 and 5.8, and they also do not have to be the same channel size. So you can actually optimize your link for throughput by using a large channel size, and you can also at the same time optimize for reliability by using a smaller channel size and cleaner spectrum. So for example, you could use maybe a 20 megahertz channel in 5.1 that has very high reliability, and then get aggressive with a large channel size in 5.8 that can deliver high throughput but may not have the best reliability. But because you are aggregating both channels, this will at least maintain the link, because your 5.1 20 megahertz channel will have a higher reliability that will maintain the overall link connection between these 2 points that you're connecting. As far as point to multi-point goes, we do have a couple of different platforms here with 450 and ePMP. So the 450 is our flagship, and we've got a few different options here even within the 450 platform, including the 450i, which was an access point launched in 2015. So this delivers some advancements like higher packets per second processing power over the legacy 450, an auxiliary port that is PoE out, so it is standard space 802.3 AT, PoE in as well as PoE out of the aux port, which allows you to daisy chain to another PoE device like a video surveillance camera without having to run another line down into your switch. It also has a dynamic interference filter, which is a much tighter bandpass filter that negates adjacent channel noise. So there is the adjacent channel rejection ratio of 40 dB. So as long as you can find a clean channel and adjacent channels are noisy, that adjacent channel rejection ratio will almost completely eliminate that noise floor and prevent it from degrading the signal to noise ratio of that active channel. The 450M was launched also fairly recently towards the end of 2016. So this delivers massive multi-user MIMO. So this is 14 by 14 multi-user MIMO, which is the ability to connect up to 7 subscriber modules simultaneously, each one of those subscriber modules communicating at 2 by 2 MIMO over the physical layer. So this allows us to achieve over a gigabit of throughput at an access point. So this can deliver 1.2 gigabits per second of aggregate throughput in a 40 megahertz channel size, or about 550 megabits per second of throughput in a 20 megahertz channel size. So this is really the most remarkable access point in the market because no one else is able to achieve multi-user MIMO, especially not to the degree or extent that we have done with 14 by 14, delivering such high throughput. So today we do support downlink multi-user MIMO, not yet uplink multi-user MIMO, but in an upcoming release of 15.3, we will support uplink multi-user MIMO up to 8 by 8, which is 4 simultaneous connections. So this is going to be a huge windfall for video surveillance because video surveillance is typically only uplink traffic where the video cameras are sending their feed up to a NOC, so they're sending it upstream to an access point. So once we support uplink multi-user MIMO with the 450M, this will be able to deliver very high throughput and high capacity to many video surveillance cameras. ePMP is a lower cost solution that's based on, again, a standards-based chip, just like the PTP550. The 450 is based on an FPGA, field programmable gate array, which allows us to deliver more complexity and to have greater flexibility in delivering the features that we wish to deliver. ePMP is more fixed because it is based on a standards-based chipset. It's based on 802.11n for the ePMP 1000 and 2000. So this was launched in 2013, and it is high quality. It's a very affordable platform, again, because it is based on a standards-based chipset. So this delivers up to around 100 megabits per second in a 20 megahertz channel size, or roughly 200 megs in a 40 megahertz channel size. The 2000 does support beamforming on the uplink. So this is a pretty nice benefit because it doesn't listen to interfering sources from 90 degrees of physical layer when it's connected to a sector antenna. It can connect to a beam steering antenna and have much tighter radiation patterns that are directed specifically towards the subscriber modules that it's listening to. The ePMP 3000 will be launching soon in the second half of this year. So this will be based on an 802.11ac Wave 2 chipset. So we have not had a Wave 1 chipset for ePMP, mostly because we didn't feel like that added much value over 802.11n. With Wave 1, it really only adds 80 megahertz channel sizes and 256 QAM. However, being able to find 80 megahertz of clean spectrum is almost impossible. So with the ePMP 3000, it is Wave 2, which on top of those additional benefits supports multi-user MIMO. So we felt that that was a greater benefit because that gives the access point the ability to connect multiple subscribers simultaneously, thereby delivering more throughput at the access point. Again, for Wi-Fi, it's not related directly to video surveillance, but if you wanted to extend Wi-Fi coverage out to areas of the network where you do have connectivity, you can do that with a Cambium CN pilot solution like the E400, 500, or 600, which are enterprise-grade indoor and outdoor Wi-Fi access points. And looking at the top, this shows our tools for planning, management, and monitoring. So Link Planner is a design tool that allows users to design any Cambium link. So this includes all devices within our portfolio. So you can plan unlicensed and licensed point-to-point and point-to-multipoint links and determine predicted throughput as well as link reliability. It takes environmental conditions into account of the different coordinates that you're putting in, and is pretty accurate when it determines what the predicted annual throughput and downtime would be. CN Maestro, again, is a homegrown solution that allows you to manage and monitor all Cambium devices, and it shows overall client health as well as alarms, allows you to push out configuration templates and even software updates, all from one single point, and it exists either on the cloud or on-premise. So for those who are more security conscious and don't want their data reaching out to the internet, you can absolutely host this internally on an on-premise server. And also, CN Archer is an app that exists for Android, and soon it will also exist on Apple smartphones. And this allows users to configure as well as align PMP 450 devices. ePMP is not yet supported by CN Archer, but it will be in the very near future. So looking more closely at ePMP and focusing specifically on the 2000 access point, this is capable of operating in the 5 gigahertz band. So this operates in 5.1, 5.2, 5.4, or 5.8, and it also accommodates different channel sizes, including 5, 10, 20, and 40 megahertz channel sizes. It is a MIMO radio, so it supports 2x2, both MIMO A and MIMO B. It is an OFDM radio. It is a gigabit Ethernet port, so it goes up to 1,000 megabits per second full duplex out of the Ethernet port. It is standards based, so 802.3 AT compliant. As far as modulation modes go, it does support BPSK up to 64 QAM and up to 220 megabits per second of aggregate capacity in a 40 megahertz channel. It does support up to 120 subscribers per access point and up to 30 dBm transmit power. Latency starts out at roughly 10 milliseconds. It says 3 to 5 milliseconds on this slide, but really that's more for the 450. The ePMP 2000 does have higher latency. ePMP in general has higher latency that starts out at roughly 10 to 15 milliseconds that does scale as you load the access point with more and more subscriber modules. However, it still stays fairly low, and it's certainly low enough for latency sensitive applications like video surveillance or voice over IP. For the physical layer, it does support GPS sync. All of our multi-point platforms do support GPS sync, which is the ability to synchronize all APs to where they all transmit at the same time and receive at the same time, because they are TDD radios, time division duplex, so they are half duplex over the air, over the physical layer. So by synchronizing all of the APs within your multi-point network, you can actually reuse frequencies because of that synchronization. So this allows you to cut your spectral footprint in half and deliver higher overall network spectral efficiency. The environmental spec is IP55. It is a plastic housing, and power consumption is fairly low at 20 watts. And on the left, we have some of the different features that it supports. So dynamic filtering, which blocks out neighboring channel interference. Again, it is roughly a 40 dB adjacent channel rejection ratio. And also with uplink beamforming, that helps to mitigate interference on the uplink and deliver higher signal to noise ratio for more throughput, especially on the uplink because of that beamforming. So taking a closer look at the beamforming concept that ePMP 2000 supports with the beam steering antenna, if there is noise, because we are steering the beam towards the desired subscribers, instead of listening to 90 degrees of overall RF, you can greatly enhance the performance on the uplink. And so this is showing a comparison of uplink performance with beamforming and without. So if there's an ePMP subscriber connected within the main lobe of the sector antenna, that AP can deliver roughly 70 megabits per second in this example. If there is an on-channel interferer within that same active channel, within that same azimuth, that ePMP subscriber module will now degrade to 10 megabits per second without beamforming. Even with beamforming, that performance is predicted to be roughly the same because it's still listening to that same azimuth where the interfering source is. However, if that interfering source moves 10 degrees and is now 10 degrees off from the desired subscriber module, then without beamforming, it will be 10 megabits per second still. With beamforming, it will improve to 20 megabits per second because now that beam is only listening to the desired SM and does not hear as much of the interfering subscriber module. And if that interfering source moves another 10 degrees to where it's 20 degrees off, Without beamforming, that will improve to 15 megabits per second. With beamforming, that improves drastically to 60. So as you can see, with just 20 degrees of separation, it operates almost as if there was no interfering source at all, which is pretty close to the 70 megabits per second we were achieving without an interfering source. So basically, as you move further and further away, that performance increases to 70 megabits per second again to where that interfering source was almost not even there. As far as the subscriber modules go, we do have a couple of options for ePMP. We do have the Force 180 and the Force 200. So the 180 is a 16 dBi gain. It's an integrated array of patch antennas that are built in. So this is a subscriber module that covers the entire 5 gigahertz band, covers all of the different channel sizes that the ePMP platform is capable of operating in. It is a MIMO radio, supports all of the modulation modes that ePMP supports, and up to 220 megabits per second of aggregate capacity. The Force 200 subscriber is a higher gain subscriber module device. So this is an 18.5-inch rigid dish design. And so this is a 25 dBi gain with some of the very similar specs to the Force 180. Other than that, it is a higher gain device, which allows customers to deliver longer distance links. So looking at 450 and how it has differentiators over not only ePMP, but the rest of the multi-point market. So this is our flagship product line. So this was built from the ground up on FPGAs. So again, that's field programmable gate arrays, which gives us the flexibility to offer a lot of the features that you could not otherwise achieve with a standards-based chipset like ePMP based on 802.11. This is a dual-core processor. So it is very high packets per second processing power. It does have the highest scalability in the industry, being able to achieve up to 238 connections simultaneously from an access point. It also supports frequency reuse. So this does not require guard bands between adjacent channels, which makes it the most spectrally efficient radio on the market. It also supports 256 QAM. And with the 450M, it does support multi-user MIMO for much higher overall throughput at the access point. And it does support a variety of frequencies, including ISM band 2.4, lightly licensed 365, which will be the CBRS band, all of 5 gig, as well as public safety 4.9, as well as 900 megahertz. And this is also compatible with CN Maestro for end-to-end management. So looking at the different options within the 450 platform, so on the far left, you have a traditional 450. This access point has been replaced by the 450i access point, and what you see in the middle is that integrated 450i AP, where the radio is integrated into the sector antenna, and all of that comprises one single chassis. So there's no external parts that you have to weatherproof or weather seal, no end mill jumpers or points of failure. And then with the 450M access point, this is the massive multi-user MIMO device that is capable of achieving 14 by 14 multi-user MIMO. So again, this is also integrated. The radio is integrated into that panel antenna, which has 56 patch antennas or 8 columns of 7 patch antennas per column. Each of those patch antennas are connected to the 7 transceivers that exist within this radio, and all of those work in unison for beamforming to multiple subscribers simultaneously, both in the downlink as well as the uplink. So taking a closer look at the 450i AP sector, this is integrated. However, we do have a connectorized version as well if you wanted to use your own external antenna. However, we do, of course, recommend that you use the Cambium antenna, because for our Cambium designed and manufactured antennas, they do have better null fill as well as better front to back ratios, which are very important for frequency reuse. So this antenna specifically is optimized for AB-AB channel reuse. It has better null fill, so even if you have subscribers that are very close to the tower that would otherwise be communicating into the null of a typical sector antenna's radiation pattern, with a Cambium sector antenna, it has better null fill to where we eliminate those nulls and prevent a scenario where subscriber modules that are very close to the tower could not communicate at all because of the radiation into a null. It also has improved gain response across the entire frequency and azimuth. So it does operate from 4.9 up to 5.9. With some of the other third-party sector antennas, you do lose a dB or two when you get into the lower 5 gigahertz range, like 5.1 or 5.2, or into the public safety 4.9. Key specs include a gain of 17 dBi. We do cover all of 3 gig as well as 4.9 up to 6.1, and we do support 90 degrees or 120 degrees of coverage. So it's a half power beam width of 90 and a 6 dB roll off of 120 degrees. The front to back ratio is very high at over 35 dB, which is higher than the industry standard of 32 dB for most third-party sector antennas. And it is over 40,000 PPS for the 450i radio. The 450M is the next generation Medusa product. So Medusa is a technology that relates to massive multi-user MIMO. So according to the 5G standard, massive multi-user MIMO is 8x8 or greater. And our 450M device takes that to another level with 14x14. So this has more than 3 times the capacity of a typical 450 or 450i device that only communicates with subscriber modules in series. So this device is able to group up to 7 subscriber modules simultaneously in order to increase that overall throughput to 550 megabits per second in a 20 megahertz channel or 1.2 gigabits per second in a 40 megahertz channel. And that is all with downlink multi-user MIMO. Once we support uplink multi-user MIMO, those maximum numbers are actually going to increase. So we allow you to protect your investment. So for customers who have already deployed 450 devices or other Cambium devices like 430s or 450is, the 450M is backwards compatible within this platform. So it will connect to 430s, 450s, and 450is without requiring a truck roll to those subscriber module locations. It does support enhanced link stability. So with beamforming both on the downlink as well as the uplink, and some gain in system gain or uplink receive sensitivity, you will see an improvement of 5 to 6 dBs on the uplink. It also has higher processing power, so over 100,000 PPS processing power. And again, this is one single device, so installation is simple. You don't have to weatherize and connect 14 end mill jumpers. All of that is built in within this chassis, which eliminates those points of failure. Some of the subscriber module options that exist within 450 include the 450B, which is relatively new. So the 450B mid gain and high gain do look fairly similar to the Force 180 and Force 200, and the specs are also fairly similar with a 17 dBi gain for the 450B mid gain and 25 dBi gain for the 450B high gain. So this is a new FPGA and system on a chip architecture. So it has enhanced processing power relative to a 450. So that's about 45,000 PPS processing power. These are wideband radios, so they do support public safety 4.9 up to 5.8. It is a gigabit Ethernet port. It does have an audio jack, so it no longer has that auxiliary port. And this is one of the differentiators that 450i has over 450 or 450B, where 450i has an auxiliary port that is 802.3 power out, which is pretty important for video surveillance applications, because if you wanted to just daisy chain PoE out from a subscriber module directly to a video surveillance camera, you can do that with a 450i, but you can't do that with a 450 or a 450B. Taking a closer look at the point-to-point portfolio that we have. So looking at sub 6 gigahertz, we do have PTP 450i, which is based on the ePMP platform, but customized for backhaul, where the scheduler has been removed. We also have the PTP 550, which again is based on an 802.11ac chipset, delivering up to 1.4 gigabits per second of aggregate throughput. The 670 and the 700, which is based on the 670, but really more for federal and defense applications. And the 670 is the most robust, has the highest mean time before failure, has the most intelligence built in, and highest spectral efficiency as well. But that only delivers up to 450 megabits per second in a 45 megahertz channel size. As far as licensed microwave goes, we have the 820 platform, and we have single core and dual core radios. We also have high-powered radios. The 820C HP hasn't been announced yet, but it will be in the near future. So that is a very high-power device that is capable of delivering over 33 dBm transmit power, which is much higher transmit power than the typical 820C. And then the RFU-S HP is also another high-power device. Both of these high-power devices not only deliver high power, but they also support field replaceable diplexers, which makes spares much simpler relative to the subband specific radios with the 820S and 820C. The 820G is a rack mountable indoor device, and this connects to an RFU-C or an RFU-A. So the RFU-C is for a split mount architecture. So this would communicate via coax to the 820G, and then that would then connect directly to the dish. The RFU-A would connect to the 820G as well, but this is a high power all indoor RF unit, which would then be rack mounted and then connect to a dish via waveguide. So all of these devices within the overall 820 platform are capable of communicating in up to 80 megahertz channel sizes and deliver up to 2048 QAM. So with a very high modulation mode like 1024 QAM or 2048 QAM, just depending on the channel size, we can deliver up to 500 or 600 megabits per second full duplex in a single core. So with a dual core device like an 820C or 820C HP with 80 megahertz channels, we can deliver up to 1.2 gigabits per second full duplex, which is more for very high throughput microwave backhaul transport. So cnMaestro is one dashboard for an end-to-end network. So this allows you to see the status of the entire Cambium network. So today this does support ePMP, PMP450, as well as Wi-Fi. It doesn't yet support the PTP670 or PTP820. However, it will in the near future. So this allows you to manage and monitor your overall Cambium network, as well as drill down into the different alarms. And you can also use this for troubleshooting. So there is a tools tab that allows you to look at each of these devices, and from the device that will actually show the connections from that edge device to the origin of bandwidth. So as you can see from this illustration, it shows an access point connected to a subscriber module connected to a Wi-Fi device. So if someone is complaining about poor performance on a single device, you can use this for troubleshooting and determining where that root cause of that failure lies. So just to recap, looking at the benefits of a Cambium network for providing wireless connectivity to your video surveillance cameras, we do support high performance. So we have low latency, high throughput applications or solutions like PMP450, ePMP, and some of our backhaul for providing connectivity for your video security solutions. We also support scalability and security. So with PMP450, we can scale up to 238 subscribers. With ePMP, we can scale up to 60 to 120 subscribers off of an individual access point. And also, as far as security goes, we do support 128 and 256-bit AES encryption, layer 2 and layer 3 firewall rules, and different user level support, as well as HTTPS and SSH support. Fast installation, again, because these are wireless devices, they are very easy to install, and installation takes hours instead of having to worry about deploying a wired architecture, which can take days or even months, especially if you're trenching. Flexible architecture, so we do support hub and spoke or ring architectures and linear architectures using a combination of PMP450, ePMP, as well as unlicensed and licensed PTP backhaul. And all of this can be managed and monitored using our free tools. You can design a network before you deploy it using a link planner, and you can certainly manage and monitor it using cnMaestro, whether that exists on the cloud or on-premise. Again, just reviewing some of the key technologies that Cambium offers. We do support beamforming and beam steering. So this is with the ePMP 2000 and the beam steering antenna, as well as PMP450M with the massive multi-user MIMO. Is capable of not only grouping, but also beamforming and steering an RF radiation pattern towards the desired subscriber modules, both on the downlink as well as on the uplink, which will minimize noise and improve the overall signal to noise ratio to spend more time in the higher modulation modes and increase your overall average throughput. Frequency reuse, we do support synchronization across all of our point-to-multipoint platforms, which allows you to reuse frequencies in front-to-back deployments to reduce your overall spectral usage and improve your overall spectral efficiency for your entire network. Intelligent filtering, again, with that 40 dB adjacent channel rejection ratio, this helps to improve SNR for devices that do support this with the 450i as well as the ePMP 2000. And also with multi-user MIMO, which is specific to the 450M, this does give us the ability to deliver very high throughput of over a gig in a 40 megahertz channel. So that's all I have for video surveillance backhaul. Does anyone have any questions? Feel free to raise your hand and type in your questions into the chat box, or we can unmute you so that you can ask your question. So I'm not seeing any questions. I'm not seeing anyone raising their hands either. So if there are no other questions, thank you very much for joining this webinar, and we look forward to seeing you again on the next webinar. Thank you.